Okay, so another proof here. So we're looking to show, again, it looks like there's no given, so we've got to interpret it from the diagram. What we will say is that's what we got to prove, DB congruent to CB. Now, one of the things that tend to be mistakes is we don't know that to be true. We're trying to prove it. So that's what we're going to work towards. What we can do is it looks like it's given that angle D is congruent to angle C, and it also looks like it's given that AB is congruent to EB. Okay, so let's assume those are given since they're not listed, but they are marked. What we can get on our own, other than the givens, is that those vertical angles are congruent. And what I think we can prove now is that triangle A to D to B is going to be congruent to triangle. Let's get the letters right. A doesn't have a mark, neither does E, so they must be the same. D is, yep, going to match with C, and then of course B. And that's going to be by, looks to me like it's angle, angle, side. Okay, so the pairs of angles here, and that's two of those. And I always tell my students, do you put the S between or after? Well, between, it would be right here, would be marked. It's not, so it's after. So it's angle, angle, side. That's our pre-proofing, that's our plan. So let's put that together as statements and reasons. Okay, so what I have first is I'm looking for a pair of angles. Easiest one I can use is the given. Okay, so angle D is going to be congruent to angle C. That was given. So that checks off that. Now we got a pair of angles, so let's go for the vertical angles. Angle AD, sorry, ABD. So angle ABD is congruent to angle EBC. And that's by vertical angles theorem. Vertical angles, I'll just write it out, are congruent. Okay. Now we want for the pair of sides, because now we're looking at an S pair of sides, and it's given. It's marked, so we'll assume it's given. AB is congruent to EB. Okay, and all right, that was given. Now the triangles are congruent by side, oh sorry, angle, angle, side, triangle congruence theorem. All right, and now we can say what we wanted to, which is a DB congruent to CB. No, that can't be right. Yes, CB. And that is by corresponding parts of congruent triangles are congruent. Okay, there's your congruent triangles in step 4. So that's why we get to talk about congruent triangles. And, we know that that is now going to work. Okay, another proof. Looks like the givens are actually stated this time. V is the midpoint of xz, so we've got to cut xz in half, 2 equal parts. Good. It's marked at x. No, that can't be right. XZ cannot be parallel to ZW. That's probably supposed to be XY. Let's assume that's XY because it's already marked. They must mean XY is parallel to ZW. That's going to get us, looks like if we check out this N, sort of, right? See this N? We're going to use the inside corners of that for our alternate interior angles. Okay, and then of course we can, on our own, we can add in vertical angles. So we're going to get the triangles congruent. Let's call it WVZ. That's going to end up being congruent to YVX. that's going to be by, looks like angle side, looks like angle side again. Yeah. All right. So looks good. Okay. Look for a pair of angles. It's going to take us a step to get those, but let's go with these alternate interior angles. The first statement is XY is actually parallel to ZW, and that's given. A conclusion from that is that angle ZWV is going to be congruent to angle. Got to use a three-letter path because there's two possible W's. So ZWV, and then we're going to use what? ZWV. So XYV. XYV. Okay, and that's because of alternate interior angles. And if your teacher doesn't let you, write the shortcut, I'll write it out this time. Alternate interior angles are congruent when parallel lines are cut by a transversal. Because that's describing the situation here. Okay. So the word theorem simply eliminates a lot of this writing. Alternate interior angles theorem. That's what it is. All right. So let's see. That just gets us one pair of angles. Okay. The other pair of angles we needed, right? We're going through our checklist, would be the vertical. So let's go WVZ congruent to angle YVX. That's by vertical angles are congruent. And then number 4 is the sides. We can't do that directly though. We need the midpoint. So V is the midpoint of XZ. Okay, and then that was given. Now we can use that to get the sides. XV, or it doesn't matter. So 5 is ZV congruent to XV, and that's by definition of midpoint. All right, almost done. So now 6, the triangles are finally congruent. Let's see what those were. WVZ is going to be congruent to triangle YVX, and that is by angle side triangle congruence theorem. Okay, and then we have YV congruent to WV. YV congruent to WV. Yep, that works. And that's by, again, corresponding parts of congruent triangles are congruent. Okay, so that's it for this video, and I'll pick up the rest of them on the next one.